Hi everybody, this video is going to talk about parallel and perpendicular lines. Now, you've heard about parallel and perpendicular lines before, but we're just going to kind of start from the beginning and look at what it means for two lines to be parallel by looking at the graph and also by looking at the equation. Okay, so we're going to start off here. We're going to graph both of these lines that we have below on the same coordinate plane. So we'll do our first one in green and the second one in blue, just so we can tell the difference between them. So the first one has a y-intercept of 2, so we plot our point at 2, and then the slope is 1/2, so we go up 1, right 2, up 1, right 2. We can also start back at our y-intercept, go down 1, left 2, down 1, left 2. So let's connect, and we have our line. Okay, for the second one, we have a y-intercept of -3 and the same slope of 1/2. Now, looking at these two lines, it appears that these two lines are never going to touch. They are what we would call parallel. Parallel lines are two lines that basically run along each other, but they never intersect. They never cross. Now, looking at the equation, let's see what might make that happen. Well, in each equation, we have the same slope here of 1/2. So they have different starting points or y-intercepts, but they have the same rate of change of 1/2. So if they start in different places, each 1, right 2, they're never going to cross. So in our equation, we can tell if two lines are going to be parallel by looking at those slopes. If we have two equations where they have the same slope but different y-intercepts, then we can say those two lines are parallel. So that's our first key idea here. Parallel lines must have the same slope, different y-intercepts, okay? And we said that parallel lines will never intersect, meaning that they never cross over each other. So that's our big takeaway. So we want to be able to look at other equations and determine if those equations are parallel lines or if they're not. So for number 4 here, we're given two equations, y equals 2x minus 3 and y equals 2x plus 2. So in order to be parallel, they have to have the same slopes, which they do, but different y-intercepts, which they do. So because of that, we can say that these two equations would represent parallel lines. How do we know? They have the same slope, but different y-intercepts. Okay, that's the reasoning. That's the reasoning each time. Each time you have to explain yourself and say, how do you know? Well, it's because they have the same slope, but different y-intercepts. Now, for number 5, it's not as simple anymore. To determine if these two equations would represent parallel lines, we have to see if they have the same slope and different y-intercepts. The problem is that for my second equation here, I can tell that the slope is 3, but I can't tell by looking at this what the y-intercept is going to be. So we need to do a little bit of work here first. We need to distribute and get y by itself. So let's distribute first, and then add 1 to both sides. So we get y equals 3x plus 7. So now we're in better position to be able to determine if these two are parallel lines. So now we can see that they each have a slope of 3, so same slopes, but different y-intercepts. So yes, again, these are parallel, and the reasoning is same slope, different y-intercepts. Now another scenario we could have is maybe instead of our equation being written in point slope form, it's written in this standard form here. So again, in order to decide if these are parallel, I first need to solve this equation for y. So we'll add 4x to both sides first, divide everything by 4, and we get y equals x plus 5. Now, We can tell we have a slope of 1 for each of these, different y-intercepts, so again, they're parallel. Now for number 7, we're back to having one of our equations in point slope form. So let's distribute. Subtract 2. And here it is. So now we can see our two equations have the same slope, but we have an issue. They have the same y-intercept. Now, we said parallel lines have to have the same slope and different y-intercepts. So these two lines are not parallel. And let's think about what this would mean. If I have two lines with the same y-intercepts and the same slopes, I have two of the same lines. And if I graph one of those lines and then the second one's the same, that means the second one is right on top of the first. So they're not parallel anymore. They're actually touching always. Parallel lines never touch, and if I have two of the same line, now all of their points are shared. They're always touching, so not parallel. Now for number 8 here, the last one. If you were asked to make your own example of two parallel lines, all you would need to do is write really any equation. So I'm going to do y equals 5x minus 10. Now, to write a parallel line, an equation for a line that's parallel to this, I just have to make sure that my second equation has that same slope of 5, but a different y-intercept. And now I would have two parallel lines. So it's that simple. Now, this is just what we do for parallel lines. Let's talk about perpendicular lines. So let's start back with our graph. We have two equations again. Let's graph each of them and see what it looks like on our coordinate plane. So again, I'll go green and blue here. So the green one has a y-intercept of 1, slope of 1/2. So I go up 1, right 2. Down 1, left 2. We'll go ahead and connect those points. Now for the second, we have a y-intercept of 2 and a slope of -2. So I'm going to write this as -2 over 1. That tells me I need to go down 2, right 1. Or I can go up 2, left 1. Now we can clearly see here that they're no longer parallel. They are intersecting. And specifically, a little more detail here, it looks like they're intersecting at a right angle. Now, when we have two lines that intersect and make a right angle or a 90-degree angle, that's what we would call two perpendicular lines. By definition, perpendicular lines intersect at a right angle. Now, we can't just eyeball it, though. We have to be able to prove that these two lines are actually perpendicular. So how do we tell? Well, we go to our equations. Now, the problem is there's no number in common that you can immediately see. The relationship comes down to the slope. So our first one has a slope of 1/2. Our second equation here has a slope of -2. Now, these slopes are not the same, but the relationship between these slopes is what makes our line perpendicular. The relationship here is that these are what we would call opposite reciprocal slope. It means they have opposite signs, and then the numbers that are there are reciprocal to one another. So a reciprocal, I like to think of it as a taking your fraction, and it's really just like flipping your fraction over. So if I took 1/2, sorry, I'm making a mess here, but if I take 1/2 and flip it over, that's the reciprocal. The reciprocal of 1 over 2 is 2 over 1. So that's my reciprocal. The opposite reciprocal would be changing the sign to negative, and if I have -2 over 1, that's really just -2, and that's the slope that we found in our second equation. So when we have slopes that are opposite reciprocals, that makes two perpendicular lines. So that's our second key idea here. Perpendicular lines intersect at a 90-degree angle or a right angle, and the slopes are opposite reciprocals. Now, the y-intercepts, though, can be the same, they can be different, it doesn't matter. It's not like parallel lines where we had to have different y-intercepts. We can have different or the same y-intercepts for perpendicular lines. So we're really only concerned with the slope here. Now let's take a look at a few more of these, okay? Now, for 16, let's say we have these two equations here. How do I tell if they're perpendicular? Well, I'm going to look at their slopes. My first has a slope of 1/2. My second has a slope of -2. So we need to determine, are these opposite reciprocal slopes? So again, let's think of 1/2. If I change the sign, it becomes negative, and if I flip the fraction, it becomes 2/1, which would be -2, which is what I have here. So yes, these are perpendicular. How do we know? They have opposite reciprocal slopes. Okay, and that's going to be our reasoning every single time. So let's look at it in a slightly different format here. Y equals 3x plus 4, that has a slope of 3. And if I have something in point slope form, I don't even need to solve for y this time because I don't need to know the y-intercept. I just need to know the slope. But the point slope form gives us the slope. It's this number in front of the parentheses. So our second one here has a slope of 1/3. So let's check. If I have 3, that's really 3/1. So if we're finding the opposite reciprocal of 3, we would change the sign, make it negative, and then flip the fraction to get -1/3. Now, the problem is the second slope that we have is a positive 1/3. Okay? Positive 1/3 is not a negative 1/3, so these aren't opposite reciprocals, meaning these two equations are not parallel lines. Now, again, the other way you could see this is maybe your equation is written in this standard form. Now, so I need to find the slope, so we're going to solve for y here. So I'll subtract 3x from both sides first, and then divide by 4. And now we can see that our first equation has a slope of 4/3. Our second equation has a slope of -3/4. So is the reciprocal, or the opposite reciprocal of 4/3, -3/4? That's what we're trying to determine. Well, if we flip the sign, we would get a negative, and then if we flipped our fraction, we would get 3/4. So yes, the opposite reciprocal of 4/3 is -3/4. So again, we're going to say, yes, these are perpendicular, and our reasoning is they have opposite reciprocal slopes. Now, we're going to pause the video there, okay, end it right there for today. If you need to rewind or rewatch, please do so, and please make sure you ask questions if you have them. Have a great day.